Good evening, ladies and gentlemen. Welcome to Atlantic Bushcraft Adventures. Tonight we are on episode 248, and I thought we'd chat a little about solar tonight. So, solar panels, charging systems, the whole array of it. The reality is, I still get a lot of questions, or more specifically, I get that person that's like, I'd love to take a little solar with me, but I don't know the first thing about it. And then they proceed with the questions on, wattage and amperage and storage and stuff like that. So I thought we'd talk a little bit about it tonight and kind of give a quick idea for people that want to get into it. Some of the stuff you should know. I am going to give the disclaimer right up here at front. When in doubt, contact a licensed electrician. They'll have all of the answers for you and all the certifications and stuff like that, depending on how far you want to get into it. The other thing I'm going to throw out there, there's going to be some math involved in tonight's episode. Maybe a notepad if this is something that you're really interested in, or at least a save for later button so you can come back and reference some of this stuff. Because I am going to rhyme some basic things off and then encourage you folks to get out there and do a little exploring and research of your own, because that's what kind of makes all this fun. Now, first and foremost, Ben, you have a great starting system. And we've talked about this in the past. I'm going to get you to kind of go over it one more time, and I'm going to grab a drink of water and close my door so the dogs don't bug us.
Yeah, so I went with, and I'll mention the brand. It's not nothing that I'm like sold on, although I've had really good luck with it. Was Pecron, and so the thing with that one is there was a good sale on when I bought it. I really compared it to a whole bunch of others, and the general reviews was this one sold a solid product with the battery type I wanted, and you could get solar panels with it. And I bought a kit, and I think I got a really good deal. And when I compared it to I think it's Blueits or something, and then there was EcoFlow and a bunch of others that I looked at. I felt like I was getting more bang for my buck with the Pecron system, and that the niceties the other ones had weren't worth the extra money for me. Now, that isn't to say it's not for you, but there is definitely something to understand with these things. You really want to understand your battery type, because your battery type is really going to decide a lot of things, and one of those things, one very clear thing for that, is how many charges you can get and how heavy it's going to be. And those are two factors you really have to take into account. And so this technology is changing constantly, and I'm not going to try to date this podcast, because someone could be listening to this in 6 months, and then everything we say will be gone for that. So really understand what kind of battery you're getting, how long it is expected to be able to last, and what kind of degradation will it take over years as you charge it, and then also how heavy is that battery for what you're getting. So they could make a really efficient and great battery, but it weighs a ton for a bunch of watt hours. Then all of a sudden it's efficient, and if you're never going to leave your yard and you can run extension cords to it, that's great. But if you're traveling, you need something that's both light and powerful and dense, basically, for power. So the one I went with, I guess I could say it, but it's not necessarily, is a Life Pro. So lithium iron phosphate 04, so phosphate oxygen 4. But it spells out lithium, Li-Fe is iron. Lithium iron is what it's called. And the lithium iron ones, at the time of my purchase, had sort of the highest amount of recharging, as opposed to the lithium ion batteries that were available. And NiCads came out even before that, and there's some problems with NiCads. They tend to go into thermal runaway, so you're looking for safety factors and stuff for that. So do your research, figure out what the best batteries for the time are and what's available. I think they're now coming out with a saltwater battery that might be comparable. I don't know.
I've seen some talk about solid state batteries rolling around here soon too, and that's going to change the game as well. And if anybody wants to find out about that, please go look it up. Interesting stuff there. So Ben definitely touched on a lot of the stuff that we're going to be talking about here and said a lot of keywords that you're going to hear throughout this podcast. So we talked about the types of batteries and the differences in the sizes of systems. So for what Ben's doing, or what I would be doing, being a lot of mobility being a factor in the deciding of what you're going to get. Like Ben said, you want something that's going to be easily, or at least able to be moved around by you. So that's going to dictate a little bit about your size and things like that. Now, some of the questions I come up with, and I'm sure Ben has had these questions asked, or has at least asked these questions is, well, how many watts do I need? How many solar panels do I need? How long is this going to last on what I'm running? And this is where a lot of people come up a little misunderstood when it comes to how these things work. And there's some great resources out there. And like I said, we're only going to touch on this stuff, folks. This is an entry level on solars. But hopefully it answers a lot of questions there. So the first one is, how many watts do I need, Ben? And I know you talked about this, not only in your storage capacity, but solar panels coming in. You know what I mean? Okay, before we talk about that, I'm backing up 1 second because I'm looking at my notes. Let's talk about the parts of an actual solar system so that everybody knows what we're talking about. So there's the solar panels, which you have, Ben. You have a couple of those. What size are yours? Just
I think I have two 200-watt panels for my Peckground system, and I think it's either 50 or 100 for my smaller system. And so the second system, I didn't intend on buying it. Just I bought something and it came with it. So I bought a trailer from a guy, and he threw in all his camping gear that came with it. And part of it was a smaller system, which we had actually been considering a similar size system for a while, because we wanted something for when I wasn't dragging the fridge and everything else around, something that would be smaller. Possibly I could push into the side of the motorcycle, or if I needed to, like, or if I wanted to go a little bit lighter. None of these things are ultralight that you're going to want to be dragging necessarily as an ultralight backpacker. This isn't really a thing. There are some solar panels you can use that will assist with that, but you're looking at a very small. Yeah. Nice. He's probably going to pull out his Burns Electric solar.
The man knows.
I have the same one. With that and a small power supply, so like the pocket-sized ones you use to charge your phone once or twice, you can actually, depending on what you're doing, it's definitely great for extending small electronic devices. So your phone, if your phone is good for 1 day without charging, which for modern phones is about average, especially you can get more if you don't use them. So if you don't turn the screen on, if you put it in airplane mode, you do all this stuff, you can oftentimes get, even a couple of days use on it. But if you're checking your email, you're watching videos, you're using a flashlight, these things aren't going to last as long. So, yeah. Now, like batteries, your solar panels are getting better and better, and they'll soon hit their theoretical limit of how much we can reasonably get out of them. And at that point, we're going to have to look at other alternatives. So the parts you're looking at is, we can start with the solar panel, if you're calling the solar system, is something that can capture the energy and send it to a device for storage.
And I listed that as the storage device.
So your storage device traditionally is some kind of battery. And attached to that battery, there's a few things. And so when you buy a ready-made system, you're going to have a charge controller. You're probably going to have some kind of power outputs, because we want different types of power. Some things need 12 volts. Some things need like USB, which is generally 5 volts. And then some things are going to need household power. So 120 hertz here in North America, 240 if you're in other places in the world. So you need some kind of inverter for that. So when you gather all that together and put it in one device, which is what I have, and there's, there are a few things, like I have a wireless charger on mine and other foolishness. But what you do is you think about, what am I going to be charging? Because if you're never going to need 120, you can save a lot of weight by dropping the inverter. Right? You don't.
Oh, absolutely. And I guess a little insight on this on my side of it is, I'm looking at building like a solar building down on this new property that I'm working on. So I'm going to be going with a larger system that I'm not going to be running portably. So I'm looking at going bigger batteries and running everything 12 volt. But the basis is still there. I'm still going to need a charge controller or controller, as Ben mentioned, because that's what's going to actually take whatever the power is that these solar panels are bringing in and convert it to something that can be used to charge the battery and store it. Because it's not going to be mobile. I have all kinds of room for an inverter if I want it, and I'll probably install one in there for limited things like charging my laptop and stuff. But for running my lights and stuff, I'm going to try and go with a true 12 volt system. So a lot of 12 volt LEDs, things like that. Ideally, I shouldn't need an inverter into the building. Now, that being said, of course, I'm still going to have an inverter in there because, like I said, I'm going to want to charge my phone. I'm going to want to charge my laptop, stuff like that. But if you are sticking to a 12-volt system, as Ben said, save the weight, save the cost.
But honestly, 12-volt systems can run your laptop, can run your phone. You don't need an inverter. Most modern laptops are charged with USB-C. So is your phone. That's DC power. You do not need. In fact, you have some kind of converter that turns the AC in your power block. I mean, I don't know if I can show mine here, but so my laptop I'm using right now, it is not even a modern laptop. I mean, it's pretty well out of date now, but it has one of these power supply blocks on it. And that's what this does. This takes AC, turns it to DC, so I can charge my laptop. The reality is, with my Pecron unit, for instance, there is I can't remember, it's like a 90-watt out USB-C slot that I can use for charging larger electronic devices like laptops, like iPads and things like that. Anything that uses USB can be charged with that at a high rate. And in 12-volt systems, you think about anything you can plug into your car. The expense with an inverter is you're taking DC power and making it into AC. And when you do that, you always lose. It's never a 1-for-1. So it's really a 1 for 1.8 or 1.9. The best inverters all have some kind of loss. They're also running a fan to keep themselves cool. There's loss to heat. There's loss to devices to keep them cool so they work longer and last. And there's other little moving things in there that are power to do this thing. So if you're running an inverter, you're not getting the full efficiency. That being said, some things have to go AC. So, but you'd be surprised how many things generally work on DC, but have a converter built into them to take that AC and turn it into a DC.
Most desktop computers run on DC too. To be honest with you, if you pull in there's a 12-volt outlet on that. You can actually run half your car's stuff off a power supply from a computer.
100%. That power supply you have has 2 poles out, one running 12 volts and one running 5 volts. That's how computers have always worked. And even your old-fashioned TV, your oldest TVs generally ran on DC in the end. It converted internally. So,
nope, 100%. And just so, once again, people with notepads, AC versus DC. AC is like house power, alternating current. The poles are flipping continuously. DC, or direct current, is basically what you get from a battery source. It's a constant current, one direction.
And it is really important to understand that with AC, you have frequencies. So it's either 50 hertz, 60 hertz, or some variant of that. And there's a thing called true sine, because you can have a really cheap one that literally puts out 120 on one side and then 120 on the other side and just keeps inverting it. But it's got a square. If you put it on an oscilloscope, which is a device where you can see current, essentially, or voltages, or however you set it up, you will see that it's very abrupt. It's like on and off. Like it's a digital AC, if that makes sense, instead of an analog. An analog would be, it'll have a perfect sine wave. So it's like an S on its side all the way across. And it comes up at a nice curve and then comes down. And that's what comes in your house is a sine wave. So cheap inverters don't have sine waves, and more expensive ones do. And it's really important because some equipment can't handle a non-proper sine wave. So you get true sine, or there's different words on it. But that will affect some electronic devices that have been known to fail, including, but not limited to, expensive things like laptops and projectors and stuff like that. So if you're going to get one, make sure it has a decent inverter that isn't going to mess up your AC components.
So those of you taking notes, that's an important one. Speaking of people joining us here, we got Eric, Andrew, Danny, Steve, and Fisher, Trevor at this point. So I'm glad Danny jumped in because I know he's working on this and I'm hoping to get some of his input here. It's Danny Red Sand Adventures. If anybody looked, he made kind of a overlanding vehicle there with a on his truck. He put a cap on it, done some stuff in there, and he's actually currently looking to do a little solar stuff in there. So hopefully we give him some information. So let's back up real briefly and talk about what we've covered so far before we move on. So solar system, you need a solar panel, takes sun, sends out energy. You need a controller, so it takes that energy and uses it or converts it to something that can be stored in a battery. Good controllers will also control your charging rate so that they're not constantly charging. So imagine taking your car battery, slapping a car charger on it or a battery charger that never turns off. Eventually it's going to cook the battery. A good controller is also going to control that. So when the battery is full, it's not just constantly pumping current in and eating up your battery life. So once it goes through the controller, goes in the batteries, it's kind of sitting there as storage. It can either come out as 12, 14 volt, or it can go through an inverter to become 110 volt or 240, depending on where you are living in the world, and use that for like house appliances. So once again, solar panel, controller, storage device, and then output, be it inverter or otherwise. And once again, the system Ben has everything conveniently in one little box that you just set down, slap your solar panels onto, and bada bing, bada boom, you have usable power that's going to charge itself. So now that we're talking about charging, how long does it take to charge something? Which is a very interesting question. And I'm going to let you run with this for a little bit because I have some math to back it up afterwards.
So you may get me on a little bit of this one. So it really depends on how much power your battery can take. So if you have a large battery and it's fully dead, it's going to take a lot longer to charge than a small battery that's not much dead. So if you have taken, say you have, and a lot of these are measured in watt hours. So if you have, say, 1,000 watt hour battery and you've been running it to run a fridge for all day and you've used up 500 watt hours, then you have to put in approximately 500 watt hours in. Now, nothing, again, is a 1-for-1. So even if your solar panel is producing 500 watts in theory, you're probably not getting that full 500 watts into your battery. There's some loss throughout the system, through the chargers and all that. So you're going to take a loss. And so if you used up 500 watt hours, that means you have to put 500 watts in for 1 full hour to regain what you've lost. So if you have a solar panel that is capable, it's rated at 500 watt hours, that is 500 watts. That's 500 watts in perfect sunlight in ideal conditions. Generally, you don't get that. So if you're on the equator and it's like
high noon, straight above you.
High noon, perfect time of the year where the sun is actually over the equator. And anyone who knows about the equator, there's the Tropic of Cancer and Tropic of Capricorn, is it? Where the two, and so in the summer, it's more in the northern hemisphere. In the winter, it's more in the southern hemisphere. Unless I guess you're in Alaska.
And then somewhere around the equinox there, it's about bam, straight in the middle.
So in the middle of the year, so on the, what is it, the most average day of the year. So what is it, June 21st and December 21st is the shortest and longest days of the year.
Yeah, and then your equinoxes are somewhere in between those. So like
March, equinox on the equator, no cloud, everything is perfect, and you're aimed straight at the sun. That solar panel is probably getting most of its capability. When I've been charging my 400 watts, I've never seen 400 watts come out of it. And my device does measure that. So when I have the two solar panels unfolded and aimed as best I can here in North America, I'm lucky to get 230, 240, like on the 400. So I'm getting a little better than half. So right away, I'm going to tell you, whatever you think you need for solar panel, based on pure math, probably double that.
So now that we've talked about how it all works, let's throw some math at this. So we're going to assume with this math, and those of you with notes or pens and pencils or coming back to it at the 19-minute mark, here's what we are going to make some assumptions off. We are going to assume that we are making 100% of what our solar panels can bring in. So in this instance, I'm going to use a 100-watt solar panel because nice, easy numbers. Not trying to confuse too many people with numbers here. 100-watt solar panel, we're going to assume it's getting 100 watts in, which we know isn't right. But let's assume it's 100 watts in. Most controllers, and the average is about 85% efficiency. So even though you're getting 100 watts in, your controller is only going to be able to roughly get about 85 watts to come out of that because of loss. It's either going to be dissipated as heat or whatever, right? Friction loss, which does happen with power, folks. Anyway, it's going to be lost. That's the average. Some are more efficient, some less efficient, but you can bank on about 85%. So out of your 100-watt panel, once it goes through the controller, you're only getting about 85 watts. If we have a standard car battery. Car batteries, as Ben said, are generally rated in watt hours or more commonly amp hours. Easy enough to change amp hours to watt hours because you just basically times it by, I have it here somewhere. I actually have the math. I think you charge it by 12 because it's 12 volt output. So, and that should give you about 1200 watts.
So watts are power. So power is amperage times voltage.
Yeah. So it's definitely voltage then. Thank you. So take your amp hours, times it by 12. You now have your watt hours. Let's say you want to run a light bulb. 100-watt light bulb for 1 hour takes 100 watts. It's a 100-watt-hour bulb. Actually, it doesn't. It takes significantly less if you get the high-efficiency bulbs and stuff like that. But once again, we're making assumptions here.
Totally different. Yeah.
You know what I mean? Let's assume that everything is terribly efficient or terribly inefficient and just use straight numbers on this. So if it's using 100 watts an hour and you have a 1200-watt-hour battery, ideally, you should be able to get 12 hours of time out of that, correct? Not so much, because all batteries are different, which Ben said from the get-go. So depending on the battery makeup, be it lithium-ion or lead-acid style or nickel-cadmium style or something like that, they all have cycling duties, which Ben talked about. I do encourage you folks to look that up. And let's go with a standard lead-acid battery, because I mean, that's what I'm working with, because I'm building like a solar house, you know what I mean? And I'm just going to use 12-volt deep-cycle batteries. They're lead-acids. Generally, you can only go to about 50% or 40% dead with those things. If you drop them straight down, you're not going to get the true output on them anyway. Car batteries are even a little less than that. So we're actually only going to get about half the wattage of that, which means 600 watts. I'm only going to get 6 hours of battery time running that 100-watt bulb that's eating up all 100 watts. Now to charge that, if I'm using the same 100-watt panel that we've been talking about, once again, getting all peak efficiency here, take out the 15% for the 85% efficiency on our controller. We're looking at about 85 watts. Divide 12 volts, because power equals watts times volts. We're getting about 7.08 amps. And I did some quick math on this before we started to make sure it was right. So it's 7.08 amps is what's coming in. If we have a 100 amp hour battery and it is stone dead, which we already said we can't do, but we're going to pretend it can, you're looking at about 14 hours to charge that in pure 100-watt fashion coming in, which Ben already said, if you're lucky to get half of that, you're actually rocking. So more realistically, you're looking at 24 hours to charge that battery of constant sunlight. That's not charging overnight, obviously, no sun. So you're looking at like 2 days to charge this thing.
So I did a lot of experimenting last year with my system, and I think my system is robustly built. And it was exciting because the way I did the math, I calculated out, I calculated my risks and stuff, that the devices I wanted to run should not burn more than half of what I was capable of in a 24-hour period. And in that 24-hour period, I was hoping I could get enough sunlight on the average day, assuming everything, that I could recharge it every day fully. So I have,
excuse me,
in theory, 400 watts that I can put into the system. I have a 1500-watt system to work with. I only plan on using 750 watt hours of that. So 750 for a 24-hour period with a 400-watt charger means I only have to get 2 hours of pure sunlight or 4 hours of average sunlight to charge that system. And that is doable. I can get 4 hours of sunlight most days.
Yeah, of good sunlight.
Yeah. And so if you're aiming for around noon, all you need to do is run that system, say from 10 o'clock to 2 o'clock, and you're really comfortable. You should really be able to get that power. But that's the thing. You have to think about, what is my daily consumption? You don't really even care what your system is capable of. What is my daily consumption? And what is a reasonable amount of power I can get per day? And if I can't, what alternatives do I have? So is there enough reserve in the system to go a second day and maybe recover it? And realize at some point it's diminishing returns. So if you go to the second day and you can pretty well make the power you originally planned, so you're still just, at the next day, the next morning when you wake up, you're probably bouncing off zero. You're near empty in power again. And then you're hoping on the third day you get twice as much sun to regain yourself. Now, if you have access to household power, even if you can get it for a couple hours, you get a household charger, you can easily get 500 watts directly out of household power off the charger that comes with my battery system. If I can plug it into my 12-volt car, I could charge it from that. And a lot of people thinking, oh, well, great. You go for a 2-hour drive a day, you can charge it up. No, absolutely not. A good running guess is you're probably only able to pull maybe 10 amps through your cigarette lighter, maybe 15, but let's assume the system is going to limit you at around 10. That means you can pull 120 watts an hour out of that system. So in that case, when I was driving and my fridge was running, which is running about 60 watts when it's plugged in, I barely came ahead. Like I was gaining a few percent. Like whenever I parked, I was more power than when I'd left, but I wasn't charging per se. I was better than maintaining, and that's about it. So in that case, you may want to consider an inverter that you can plug into your car to produce more wattage straight off the system, right to the battery, or right off your alternator, ideally. That would make that difference.
So one thing I want to address before we move on, because Danny is asking us some questions here, and I'm going to address them for him. So to run through what he's saying here, I have a 90-watt solar panel and a controller. I also have a dual battery isolator in my truck, so when the truck is running, it charges my camper battery. I'm also thinking of using these two systems together, and it should be okay. Probably going to use a 100-amp-hour battery, since I'm in the truck and usually start the truck and travel every day. Just make sure you use the right deep cycle battery, not a marine battery. Marine batteries are made to provide a big burst of power to start an engine. Okay, gonna straighten out some things here first, Danny. Go ahead, Ben.
Actually, so he's 100% right with the marine batteries. They're called deep cycle starter batteries, and what they are is a hybrid, and they're neither a deep cycle battery or a starter battery, but somewhere in between. And so they cannot handle a full discharge nearly as well as a proper deep cycle. In fact, it is rather difficult to find a good deep cycle battery without going to a specialty shop.
Yep.
If you go to your Walmart's, Canadian Tires, and look for a deep cycle, almost invariably, you're going to end up with, unless it's being sold as a solar battery or something like that, you're most likely getting a starter battery. And so they are not as good for that fact. But this trade-off is you can take a lot of amperage out of it really quickly to start a vehicle. And that's why a starter battery is what it is. You can pull like 900 watts out of these things really quickly. And that's what kickstarts your car. Not overly great for a deep cycle battery because most of those are more limited. The peak amp that you'll get out of a single go from it without damaging the battery is lower, but you can do it for much longer.
And that's the thing, just to throw my 2 cents in there. So first and foremost, deep cycle marine batteries work fine in solar systems alone. You can't use them to run the car, which is what Danny's saying over here. Like Ben said, the constant big blast they need to start a car, it'll do it, but it's going to wear the battery out really quick in layman's terms. It's going to burn it up, honestly. But for the solar side of things only, and if Danny's doing this right, it wouldn't be too bad because they do hold battery good and they discharge at a low rate, like Ben said, really well. If you can get a proper deep cycle solar battery, even better. But in a pinch, I'm going to use deep cycle marine batteries in mine, but I'm never starting a vehicle with it. I'm going to simply run it directly off solar. So I shouldn't have too many problems. In your setup, Danny, yes, you should ideally, so should I, honestly, but even more so you should get a proper deep cycle battery.
But there's another thing going on with his, and this works too. If you're in a vehicle and hooked to the vehicle, it's most likely getting a much better charge from your alternator. So when you're doing that, and then every time you're parked, your solar panel is helping keep it topped up. So there is a balance you can find. It's not a bad system per se. You are generally better off looking for, right now, lithiums are really good. So lithium iron is the one I went with. They can, I think it's 3,000 full discharges or recharges before you start to see degradation.
Yeah, that's lithium ion phosphate is the one that you're talking about. I looked it up.
Essentially, you're looking at between 3,000 and 5,000, depending on the spec you read. So at 360 days a year, and let's say you don't do it every day, but let's say most days, so 300 days a year, you're looking at something that could theoretically last regular use for 10 years.
Yeah, absolutely.
Right? So a really good system. Other ones, like I think the lithium irons were more like 1,000 or 1,500. They were significantly less. Newer battery systems that'll come out, I'm sure, will be even better. And so these better systems will definitely matter. So that counts. Also, internal resistances, how much it can take to charge it, how much effort, like how much resistance it takes to charge, also plays a factor in this. So you need to understand all this stuff, and you don't need to know it 100%. But
you need a starting point to do the research, and that's all we're trying to offer.
When you go to build a system, ask the people and make sure that things match. Like a charge controller for a lead acid battery is not the same as a lithium battery. And that's because the batteries are set charge slightly different. And even the voltages they can handle for charging varies. And if you try to put too much volts in a battery to charge it, you can fry it, you can boil it, or you can cause it to overheat. And if you don't put enough in it, it just won't take it. So you need to find that variable. And all batteries kind of need to be charged correctly. So sometimes they can take, when they're low, they can take a fair bit. But then as they get closer to the top, you slow down the charging rate.
And that's what a good controller is going to do for you, too. Just to throw this out here, not really solar, if you did want to make a system out of normal car batteries, you're better off using a windmill with a car alternator and a modulator attached to it, or a rectifier or an internal magneto or something like that to regulate that voltage. But anyway, real easy thing to do. I've done it, and it works fairly well.
The other thing is, if you're going to use car batteries, use a lot of them. Like, yeah, honestly, if you're not going to use one that can be fully discharged, you're much better off having a bank that's overkill, where you will probably never go below 20%, because a lead acid battery will last super long if you never drop it below 20%. So look at the weight, size, volume, and cost. And if you can get your hands on a lot of lead acid batteries way cheaper, because let's face it, the lithium ion ones are expensive. The lithium iron ones are even worse. If you have the space and the ability to deal with it, and even like the maintenance ability, you can do more maintenance on a lead acid battery. If you can do that and monitor it, and this is the other thing, you can monitor the charges. You can find your bad battery. Bad battery will pull down your whole batch. That is possibly the cheaper way to do it. It's just, who has room to have 10 batteries when they could have used 2?
Now, I'm going down this road. I'm going to use the 10 batteries, but I'm building a rack for mine in a building, which isn't going to move. I'm going to use good old-fashioned batteries, you know what I mean? And I'm just going to have a basic system and run it exactly what Ben said, cost versus what I'm getting out of it.
So you can run down to the local junkyard and buy some refurbished batteries from them, probably $30-40 a piece, maybe no more than 50. And you can get a shit ton of batteries, or look for sales. Like I found, I did this years ago, a whole bunch of the line tractor batteries.
Yep,
and they're not big, but you can pick up a whole bunch of them. Other thing you can do with that is run some of them in series and some in parallel, which means you can move it from a 12-volt system to a 24-volt system.
24, 36, or 48, however you want to put them in series. Once again, folks, if you're going to start doing this stuff, look it up and understand what each one does. So when you put batteries in series, you're adding the voltage up. When you put them in tandem, you're adding the storage up. Do the rest of the research from there.
Your output remains the same, as in your same amount of watts you can get out of it. The question is, are you putting in more voltage or more amperage?
Exactly.
But the math works. Yeah, so that's sort of it. So the big thing though is figure what am I charging, or what am I using the power for? How much do I reasonably expect to use in a given period of time, and how much power do I expect to be able to get in that given period of time from the solar system? Because your batteries, they run all the time. They're a 24-hour system, but your solar system is only putting power into the system about 30% of the time. That's a pretty good number, actually. In a good summer, like midsummer, longest day of the year, you might be able to get 12 hours of charging out of them. The rest of the time, the sun is either too high or too low to get real power out of them. And also realize you're going to have to readjust the solar panels probably at least every hour.
Yep.
So when I'm doing it, like I set mine up, I'll oftentimes set them up so they're not quite right, so that when the sun moves in about 30 minutes, it will be right. And then when it's 30 minutes the other way, it's just as bad on the other side, but I'm still getting some charge. And then I got to go in and I got to tweak them again. It's just a few degrees, but it's something you have to do. Unless the system is designed to move with the sun, if they're completely stationary, you're only going to get sun probably for the brightest hours of the day. Most people aim them to work from the peak when the sun is at its
Southeast
point.
aspect.
Yeah, for 1 to 2 hours before and 1 to 2 hours after, they'll get the best power, and that's the way the system is run. Again, if in doubt, get more solar panels and bigger batteries, and you can always offset, and you can have a bit more leeway to work. My system was designed to run the battery for essentially 48 hours without charging, and then with charging being able to do it in 2 to 4 hours meant that what I would expect to lose in a day, I essentially can run indefinitely. And that's with taking other things out. So I had a family of 5. We got 5 phones. We got 2 or 3 cameras. We have a couple of drones. Those are the big things. Maybe a laptop or a tablet gets thrown in there. And of course, the big thing is some lights. And the hugest thing is our refrigerator. That was the big thing for us. We wanted to keep food cold, not have to keep buying ice. And allows us to go more remotely for longer because we can keep things cold without having to access purchasable ice or other power supplies to deal with that. So that was how my system was set up. Your system is going to be kind of left alone for days at a time.
Mine is going to be a standalone system. I'm going to put in about 15 batteries, great big solar panels, aim them to the southeast, and that's it.
So that's the big thing. Figure out, and here's the other thing. You're going to have peak power, which is when your system is pulling the absolute most. Make sure that your system is capable of handling that. And then average power. So run your system, whatever you're planning on draining. There's sensors you can buy. You can plug whatever you're using into this tool, and then plug that into a wall or whatever power supply you have, and it'll tell you what the highest amperage or wattage was, what the average wattage was, and what the lowest wattage is. So you're going to get probably at least 3 numbers. So a lot of things, initial startup, surge power they call it, might pull, say, 500 watts. But then when it starts moving, it might only be using 200 watts. So if you're going to, especially with the inverters, plug something in, like, say, a SAW, that surge wattage could be enough to shut the system down. It could blow a fuse, could flick a circuit breaker, or shut the whole system down. You may have to go to a hard reset. So you need to be able to handle the surge, and then you're basing your wattage on your average use, and then your lowest usage is not really a problem. It's just nice to know. So once you know those 2 numbers, those 2 worst numbers, you kind of have to build your inverter. Your batteries need to be able to put that wattage out, so you know they can handle that output to get everything started. And then what is my average use? And then use that average use to figure out how many hours you can go using your math. Does that all make sense?
Absolutely makes sense. And the last thing I'm going to end off on here, because we are coming up on 40 minutes, is when dealing with all of this, realize that wiring is important as well. Make sure you're using the correct gauge wire to run the amperage and stuff that you want. Because if you're using speaker wire to carry heavy amperage, the friction in that the thermal is going to cook those wires. So make sure you're using correct gauge wires, all that stuff. Once again, real important to research that stuff. Larger wires generally are going to be a lower gauge, and find what works for you without going into overkill to break the bank.
The other thing, if you're building your own system, make sure that you include the appropriate size fuses for the wiring you're using and the systems you're hooked up to. So a lot of people make the mistake and think I'm buying the fuse for the item that I'm running. You're not. You're buying the fuse for the wire. So the fuse should pop before your wire burns.
Yep.
So if your wire is capable of running 500 watts, you want to put probably a 500 watt fuse in there, a fuse that will blow at that amperage times, because they're usually in amperages. So you look at your voltage, divide it, whatever that amperage is by it. So 10 amps, 15 watts amps, whatever it happens to be, and put that in. And that's to protect your wiring. Circuit breakers and fuses, people don't like to believe this. They're designed to protect the wires. If they pop, the item on the other end of the wire is pulling so much power that the wires are about to melt, and that could cause a fire, and that's your real problem. It doesn't protect your item. What it also may happen is something shorts out. It'll again protect your wire, protect your output device too. But no, it's not to protect your device. Fuses rarely do that. It's usually the device has failed and is causing the wires to potentially catch fire. So keep that in mind. And switches. If you're setting up your own system, you may want to put in some systems so you can switch banks of batteries off or on, or certain outputs off and on, or inputs even, to control your power the way you want.
And the last thing I'm going to say to Danny himself, as he was talking about, he wants to run his little diesel heater off one of these. We have been doing some experiments with the neighbors here. I think out of a standard 12-volt battery, he got 12 hours out of it or something like that. But I will double check and let you know for sure. It was one of the things he did. He just charged his battery up and was like, screw it, I'm going to see how this runs. And it was an RV battery because he was buying this to potentially provide heat in an RV. And like I said, I think it was 12 or 14 hours straight he got on low. Not high, low, but low was more than enough heat than he needed at the time.
Honestly, the one I have, I did run it. I did hook it up to to my power supply. I don't think I was pulling much more than 25 watts.
Yeah, it wasn't one, like the first startup, like you said, was a lot to get it all running. But then once it was running, it really wasn't that much wattage that thing pulled off. And he just kept it on low. And
you heat up your glow plug, you get the flame going, and then it's basically a fan that keeps the air moving is what your main source of power is after that. And a little pump that pumps the fuel in, that doesn't pull a lot of power. So if you got an efficient one, you can run it for a long time on a battery or power supply. Absolutely works. The things to keep in mind with absolutely everything is, are the connectors compatible? So if you go out and buy a set of solar panels and you're trying to plug them into a charge controller, you may have to buy adapters or rewire them yourself to make sure that's the advantage of buying a pre-made system from a pre-made company. Your solar panels are designed for your unit. They're going to hook to each other. Make sure you're hooking the solar panels up as per the manufacturer. And mine are, I think, all in series, but some may want them in parallel. That's an important thing to keep in mind. Make sure that the connectors are all set up properly and correctly, and that they are foolproof. You don't accidentally have to put everything backwards, because you could cause some pretty serious problems if you miswire something.
Oh, goodness. I mean, off a couple car batteries, if you put them in series and put it in, like, you can weld with car batteries. You can produce enough arc, you can weld with it, right? So,
my grandfather said that many a time. He said, if you get a couple of car batteries, put them up in series, hook them to a welding rod, you can get more than enough amperage and voltage out of that thing to weld together a truck or a car, or put a chassis back together, or whatever you need.
Actually done it in the woods, done some emergency repairs with it. Anyway, that's a whole other story, and we're not telling people to do it.
Not great for your batteries, and definitely not the safest thing anyone's ever done. Especially if you're using lead acid, make sure that you have good ventilation, because the fumes out of those things actually is flammable. And if you produce enough by really running the battery, you can cause an explosion. So make sure they're ventilated and all that. But yes, it will work. So those are the big things. do the research. No point in getting so much solar panels that it's more than the system can take. You are charge limited. It'll only allow so many amperes in. So if you go more than that, you're just producing power for no reason. Make sure that the system you have can put the output of what you plan on doing, both for surge and long term. And then hopefully you have enough reserve. That's what your battery size is reserve to handle probably everything you expect to times 2. So essentially, like I said, you want to double your solar panels to get the power you're expecting out of it. You want to double your amperage or your watt hours that you want, just so you have reserve and you're never really cutting into it. And when you consider how much you're draining, like what your usage are, you'll really want to consider a healthy percentage over what the manufacturer suggests those components are capable of. So if it says it's an 80 watt or 80 amp system, assume it's pulling at least 80, if not 90. But know that the written numbers usually include the surge and not the actual average runtime. So test it. Test.
Absolutely. So we're at 45 minutes. I think that's where we're going to wrap it up here tonight. What was supposed to be a quick episode, which normally does, turned out to be one of our more longer episodes, but a lot of good information here and a couple of ramblings, which is normal with us. But anyway, a lot of good information. Hopefully some of you folks come back to this. Danny said he's going to do some of the testing and designing on his channel there, so be sure to jump over to Red Sand Adventures and check out what he's doing over there. Well, and thanks for Steve, Eric, Andrew, and it's not Fish anymore. It's Trevor for all jumping on. Much appreciated. So for me tonight, thanks everybody for joining us. Be safe if you're doing anything with this. Once again, please do your research. If you have questions, ask a licensed electrician if you start getting lost. But once again, the internet's your friend. But anyway, be safe, folks. We'll see you next week.
Yeah, and the only thing I gotta say is, honestly, you can always, like, if you buy some of the stuff, you can always update. You can always upgrade your batteries later. You can always update your charger later. A lot of the stuff you can continue using for a longer time. But yeah, start somewhere, see what it works, and upgrade. Or maybe you decide to downgrade. Maybe you decide I overbuilt, or I bought a more efficient fridge and now I don't need what I have. So, just think about it. You can always resell some of that stuff and gain your stuff back, some money back, and figure it out. But yeah, get into it, try it, have fun.
Night, folks.